Introduction to the NanoMythos academic paper, cover page. This is a technical note about the recursive depth architecture hypothesis. Chapter 1, Background. Closed-source models like Claude may use a recursive depth or iterative refinement architecture, but we cannot verify this directly. The engineering approach is, implement this mechanism in a controllable open-source model and see whether it actually works. The core idea of recursive depth, not just adding layers or parameters, but reusing the same computation block. The architecture is input token embedding prelude blocks mythos core, repeated t times, coda blocks next token loss. T equals 1 is the first non-trivial setting we focus on. Model setup comparison. Both the baseline and the NanoMythos T equals 1 model have 110M parameters, the only variable is the recursive core. The baseline is a NanoHale-style small model with no recursive depth. T equals 1 inserts one recursive path into the same backbone. The experimental design has 4 elements. Dataset is the compact FineWeb-Edu 10K subset. Training budget is 5,000 steps with intermediate checkpoint evaluation. 3 random seeds avoid chance. The metric is PPL, lower is better. The core question, under the same budget, can T equals 1 lower validation perplexity? Core result, T equals 1 outperforms the baseline under all 3 seeds, with an average PPL improvement of -17.9 and a 3/3 win rate. The advantage is especially large on seed 2027, -36.3, suggesting the recursive path may have increased the model's robustness to seed instability. Training dynamics analysis. In the first 2000 steps T equals 1's advantage is weak, -2.8 to -3.7. But from 3,000 steps the gap widens to -7.7 and finally stabilizes at -9.0. This shows the recursive depth advantage is not an early optimization illusion but persists as the model fits the data distribution. GPT-2 external reference comparison. Under the same short budget, NanoWhale T equals 1, 147.7, far leads GPT-2 standard, 273.5. Although this is not a pure architecture comparison, different tokenizer, block design, etc., it supports that the backbone plus recursive depth direction is worth scaling up. Length bucket analysis. T equals 1's advantage appears in the mainstream 200 to 500 character range of the validation set and improves across all seeds. This lowers the hypothesis that the PPL improvement is driven by anomalous samples. Recursive depth has a systematic positive effect on the whole mainstream text distribution. Boundary check. T equals 2 performs poorly under the same conditions, 283.6 PPL, far worse than T equals 1, 147.7, and the baseline, 156.7. The conclusion is not to reject deeper recursion, but that T equals 2 is not plug-and-play viable under the current training configuration. Design decision. T equals 1 is the main line, T equals 2 is a secondary research path. Engineering smoke test. Training loss dropped from 23.6 to 13.8, the 200-step smoke run succeeded, checkpoints were saved correctly, and Mo plus recursive forward ran without failure. Multiprocessing launch was deferred, infrastructure configuration issue, but does not affect model-level reliability validation. Result interpretation. What we can prove is that T equals 1 recursive depth improves early pre-training efficiency on a small model. What we cannot prove is that Claude uses this architecture, that T equals 2 is ineffective, or that the gains transfer to billion-scale models. Honest boundary statements are an important part of scientific research. Next steps. 1. Run FineWeb-Edu 50K to test whether the T equals 1 advantage survives. 2. Launch a 100M 200M parameter T equals 1 pilot to validate scalability. 3. Treat T equals 2 as an independent ablation path needing lower LR, longer warm-up, etc. 4. Complete the distributed training smoke test. Summary. Baseline PPL 166.2, T equals 1 148.3, average improvement -17.9, 3/3 win rate. The most conservative conclusion, T equals 1 recursive depth is a credible architectural improvement candidate for the next scale-up phase. Next steps are the FineWeb-Edu 50K and 100M 200M pilots.